Namaskar, hello, and welcome to SwayamPrabha channel 14, the course on library automation, the unit 16 that is called the data structure, file organization, and physical database design. I am Professor Dr. Arun Kumar Chakraborty, head of the Department of Library and Information Science, Netaji Subhash Open University, Kolkata. I am the course coordinator for this paper course number 6, Information Technology and Application in Library and Information Science. I will cover now this module 2 of this database management systems unit 16, that is data structure, file organization and physical database design, because I am the subject matter experts in this unit. So this course is exactly for the learners of Masters of Library and Information Science for both Open University as well as the regular university course learner. But this course is not limited to the only the getting the credit or marks, because the students who wants to appear for competitive exams like NET, SET, Joint, etc., and also for that need different jobs, so they can update their knowledge by going through these slides, this video. So I welcome all of you. So as a library and information science professionals, you play a crucial role in managing and providing access to information. And in today's digital age, this involves in this today's digital age, it involves that essential for writing that working with databases which are storing, retrieving and managing vast amount of the data. However, designing and managing databases effectively requires a good understanding of the underlying data structure, file organization techniques and physical databases design principles. So in this course, we'll explore these fundamental concepts and provide you with a solid foundation for designing and working with the databases. And by the end of this course, you will have a better understanding of how to store, retrieve, and manage data efficiently and effectively. So let's get started on the journey. So into this world of data structure, file organizations, and physical databases design. So unit 16 is covering the data structure, file organization, physical database design. Means three components are there. So this table of component is a learner's outcome, preamble, then basic concept of the data structures, file organizations, memory of hierarchy, data structures of this, then arrays of the data, physical database design, how this data is physically database, how is the files are organized, how this memory was in, how the physical storage of the data, all these things have been discussed in this topic. What is the objective of these databases, of your learning? This learning is to understand the fundamental concepts of the data structures and the data file organization. So you have to learn the principles of the physical database design. You have to comprehend the physical storage structures of data and file organizations techniques. Apply knowledge of data structures and file organization to design efficient databases. You can gain an insight into the role which the data structures and file organization play in the overall performance and access efficiency in the databases. So unit 16 data structures, information technology applications in LIS will provide you with a comprehensive understanding of these concepts and their significance in the digital era. So after learning outcome will be, after completing this course, learners will be able to define and explain various data structures. It can be arrays, it can be a linked list, it can be stacks, it can be queues, trees, graphs, and describe different file organization techniques, sequential databases, indexed, hashed. So discuss the principle of physical database design, including data storage, access method, and query summarization. So design a simple database using a rational database management systems. RDMS is the most important, all of you know that. So identify best practices for data storage, retrieval, and management. So preamble is that the data structure and file organization refers to the method of organizing the data in a database. Data are stored in a database. How this data are stored, organized, and retrieved, that the database structure, that is the capacity of the databases. So how this data has been stored in this puppet. So they primarily deal with the physical storage of data, which assumes significance in retrieving, storing, and reorganizing the data in the databases. The performance of the database greatly depends on the data storage, structures, and file organization. So the data structures define the physical databases and design. So data structures are completely of this one. So data structures and file organizations, which are essentially to provide the necessary background for their underlining art. So understanding, what are the understanding? This why data structure. The key factor in designing the data structure and file organizations is relatively slow speed of hard disk and large amount of time that is required to get information from a disk. If you are getting from the disk, it's taking very time. Tracking the developments of data structures and file organization over the years, one finds that early work on the files presume that the files were on the tape and access is sequential. Basic concept. So memory and hierarchy. A memory or hierarchy in the context of the data is that the file organizations and physical databases design and refers to the layered structured databases of say devices of varying access, speed, and complexities. Its capacities where data is moved between level based on access patterns and with faster, smaller memory closer to the CPU and slower, larger storage further away, optimizing the data retrieval performance. So there are different basic concepts when we think of the memory hierarchy, because in the databases, if we are not memory hierarchy is not maintained, then the data structure file organization will not be in an appropriate stage and will not be able to organize the data accordingly. Because if the data stored in a process not in a retrievable condition, or it is getting slower, so that data it takes a lot of time, the people will get frustrated. So you have to respect the time of the user. So that's why the databases of the, and there are a huge kind of data, and the huge kind of data, how the data is processed because of the processor. So the processor base, that also having a good processor with a good hardware and software backup. So those kind of things, if we do not have, will not be able to, those kind of these things cannot be done. So CPU is organized. So basic concept is that key points about memory hierarchy, levels, the different levels of the hierarchy is registers. The register is that fastest, smallest memory located directly on the CPU. So we have to see that what kind of level it is there. That means what smallest, but directly on the CPU. This is and central processing unit and used for immediate calculation. Because if you are having a CPU in your own place, we can do these things very easily. Because if the CPU is not there, if it is in a cloud, we have to find out the cloud. So then cache memory. Smaller, faster memory and stores frequency of data, access data from main memory, improving access time. So this cache memory is also very important because it also depends upon your processor of the computer, because how much hard disk processor is there. So if it is a faster processor is there, so that cache memory, because whatever you search, it is stored in the cache memory. And then if the cache memory also gets increased, then your search also becomes stored, becomes slowly, searching becomes slowly, retrieval becomes slowly. That way, if your main memory RAM is also very poor, that also relatively fast access where the active working data resides. So the active resides here, so we have to know that how fast access is there. So basic components of this are registers, cache memory, main memory, and then secondary storage. What is the secondary storage? It is a hardware disk, hard disk. It's lower the access used for storing large amount of data that can be transformed to main memory as needed. So secondary storage of information, that is hard disk. Whatever we require to store the data in a hard disk, because if you use the computer, in the computer there have got a different kind of hard disk, and you have a hard disk of two different drives in the hard disk, and you can store the data in the different drives in the hard disk, so that your data manage is become easy. So how the data structure, file, and etc. are there, we have to think about this. So choice of data structure impacts access partner. Different state structures is that arrays, linked, lists, trees have different access characteristics, which influence how data is retrieved from the memory and can be optimized based on the memory hierarchy. So memory hierarchy is very of the important access pattern. So choice of data structure impacts the access pattern, that we have to remember, because array, link, trees, how these things are there. How this caching technology, caching techniques is that efficiently utilize cache memory by designing the data structure, and that allows for fast loopholes and the lookups for the frequently accessed user data. So caching technique means that efficient utilizing the cache memory by designing data. You have to see that if your cache memory is very good, the design data structure, it allows to first lookups for the frequency and access the data. And how data structure, file organization, physical database design relate to the memory hierarchy. So we have to now correlate this data structure, file organization, and physical databases. As these are the three components. We have to understand the data structure is one component, file organization is another component, and physical database design is another component, and that which are related to the memory hierarchy. Because if you are not having this data are not hierarchically memory wise, is not organized, kept, or stored, will not be able to access those data. So these kind of things we have to think of, that how this data can be done. So the choice of the data structure impacts access pattern. The different data structures, array, linked, list trees have different access characteristics, which influence how data is retrieved from the memory, and then that it can be optimized based on the memory hierarchy. Because we have to see that how this optimization of this memory hierarchy, it has been increased. And then caching techniques, how this caching technique is used, efficiently utilizing cache memory by designing data structures, and that allows for first lookups of frequently accessed data. Frequently accessed data means what are the data we immediately search, that is frequent, that's in the memory. So if it is available in the cache memory, so those data will be retrieved immediately, and that's the faster access, faster retrieval is there. So data structures and array. The data structures are building blocks of a computer science, because data is like a building block, it is being structured, and they provide a way of optimize and store data in a computer so that it can be efficiently accessed and manipulated. Because if we do not have a organized way of storing and the data in a computer, then the data retrieval will be impossible. So that is the most important part in any of the data organizing sector. The data efficiently, data, if the data sets are organized in a different components, then only you will be able to do. So what is the arrays? An array is a collection of elements of the same data typed, stored in a contiguous memory locations, and each element is identified by an index or subscription, and that's what's called subscript that allows you to access and manipulate its value. So example of this kind of data is that a list of student names can be stored in an array where each name is an element in that array. Each name will be in the array, and the examples, the data structures, linked list. A linked list is a dynamic collection of the elements where each element points to the next elements in the list. The first element comes and the next elements in the list. Then linked lists are useful for inserting and deleting elements. You have understood in the concept of the common our cataloging systems or your classification systems where it is called the interpolation and extrapolation that Ranganathan had given in our course, that interpolation and extrapolation, and that interpolation and extrapolation concept, it can be used in the library computation, not only the library computation, all the computer field. So how the Ranganathan has viewed of such kind of that data structure, because the library is a data, so he knew that this interpolation, the new books will be coming, new journals will be coming, how you will interpret and interpolate and extrapolate. So that kind of things, the databases concept is completely linked with that kind of analogy. So linked lists are useful for this purpose. So a list of books in the library can be stored in the linked list where each book is an element in the list and each element points to the next book in the list. So we are going to point each element and then element to element in the next array, because next array it comes the book. If you want to retrieve the book, it can be have a title of the book, author of the book, editing if it is the editor of the book, then the edition, price. So that numerous tags is given in the Mark 21 or in the different shades. So with that kind of things, if we are not able to recognize in that way, we will not be able to do that data. So the data structure stack queues. A stack, what is a stack? A stack is a last in first out, means it will last whoever comes and then first whoever there it will go. That is called a stack, means the last book which in the last in whatever in the last whatever we have inserted, the first whatever we inserted it will out. That's called LIFO. A stack is called LIFO. The data structure where elements are added and removed from a top of the stack. Example, a stack of plates where you add and remove plates from the top of the stacks. So what is a queue? A queue is that first in, first out. Who have entered the first, he will be going out in a first queue. Because say if you are standing in a queue for a bouquet for food, then whoever got the first, he will go out and the next one comes, next one in. So that's then the same concept. You see that the database structure is like our human concepts of human daily life. So in that queue, so the queue is a first in and first out, and the data structure where elements are added and end of this. So example is that a queue people waiting to buy tickets, where people are added to end the queue and removed from the front of the queue, because the person who got the ticket, he will go out. The next one will come in the queue. Like food counter, whoever standing in the first counter, he will get. In the book counter, whoever is getting the first book, he will get, and the next one will come, and the next one will get. So that is the queue systems. The data structures and tree and graphs. A tree is a hierarchical value and the structures which has a more use of value and zero of more child modes, and the trees are useful for storing and searching of a large amounts of databases. So that's called the a file systems where each directory is a mode on the tree and each file is a child mode and the democracy. So what is a graph? A graph is a non-linear data structure where each node is connected to the zero or more nodes, and graphs are useful for modeling and relationship between the objects. So in examples, it's socially network, examples all that that each member of social where each person in the mode is called in continuation conclusion that in the data structure what we conclude that the data structures are essential for storing and manipulating data in a computer type of the in the computer science and understanding the different types of the data structures and such as another arrays, linked list, stacks, queues, trees and graphs, and it is crucial for designing the efficient algorithms and solving the complex structure. So now I think we have understood that what is the data structure, what is the data structure tree and graphs I have discussed. Now we'll go to the next part of this program is that physical database design. So now we know the data structure, then how this physically how these databases are designed, that we will be discussing in this issue. Now the physical database is the process of creating a physical representation of a database, including the storage devices of files of this one, the organization and access. So access the methods. The goal of the physical database designed to optimize the performance of the scalability and reliability of the databases. The storage device of these databases is called that hard disk, drives, solid state device, and then flash drives, etc., and the tape drives. So file organizations. File organization refers to the way of the data are stored, retrieved from the storage devices, and common file organizations include that sequential file organization, that is data is stored in a sequential manner and retrieved is done by reading the data in the sequence. Then indexed files organizations, the data is stored with an index that provides quick access to the specific data. Then hashed files organizations, data is stored using a hash functions and that maps the data of these specific locations. So this access mode of this data is that access method refers to the techniques used for the access method, including that sequential access, data is retrieved in a sequential manner, random access, data is retrieved directly using an index or hash functions, then buffering, the data is retrieved and stored in a buffer or faster access, and then we call the database storage. Database storage refers to the way data is stored in a database. Common database storage includes the row store, because it can be stored in a row. The data is stored in rows with each row containing the columns, and the column store is that data is stored in the columns with which column containing all the rows. So how is interlinked the column and rows? So how this data structure, file organization and physical database design related to the memory hierarchy. So physical database design under this is data block allocation. This is deciding how the data is organized into the blocks on the disk to optimize the access times based on the access patterns. Then we have to talk about the clustering, grouping related data together on the disk to minimize the disk sick when accessing multiple related records. Then indexing access is the strategies designing of the indexes eligible efficient retrieval of specific data. And then the key consideration when designing a memory hierarchy, what are the key consideration we should do that? That's called the locality of the references. The locality of the references is that the principle that is accessed frequently trends to close together in memory is the data access patterns, the understanding the how the data is stored and typically accessed sequential or random, then data size and volume, the amount of the data storage, then see this memory hierarchy, because that's one level, one design and all if you can see it. So memory hierarchy design, it is registers, cache memory, we have done it, then main memory, types of main memory, static RAM, secondary RAM, secondary storage. The secondary storage such as hard disk drives and then state drives, that solid state drives in a non-volatile memory unit, and that has a larger storage capacity than the main storage of the capacity. So memory hierarchy is that design is that magnetic disk. Magnetic disk work as a high speed inside the computer, and these are frequently used. Then magnetic tape is the backup of a data. So what are the characteristics of the memory hierarchy? Is that capacity, access time, performance, and then cost per bit. So system approach is that important, is that according to the memory hierarchy systems, you can see the level 1, level 2, how this directory, what kind of size is there. So that kind of comparisons you can see and you can feel that one. What are the best practices of the physical database design? Here are the some best practices for the physical database design that use a combination of storage device and file organizations to optimize the performance. Use the indexing and hashing to improve the data material retrieval. Use the buffering to improve the data access. Monitor and optimize database performance regularly. And then the file and their organizations. A file is a sequence. Now I'll come on the file and their organization. A file is a sequence of records, and file organization refers to the physical layout or structure of a record occurrences in the file. And file organization determines the way records are stored and accessed. A file have established of this one variable length. A file records are same record type, and that one more fields are varying size of this one. So files and their organization. The file records is that the file records are the same record type, but one or more fields may have a multiple values for individual records. Such a field called repeating field and group of repeat valuables. You have used the CDS ICs, Win ICs are told that's the repeated field. In all every cases that is a repeated field is there. The file records are the same record types, but one or more fields are optional. The file has the records of different record types and hence the varying size mixed file, and this would occur if related records or different types were clustered and fleshed together on the disk block. So file organization structure, you can see that how this sequential access mode, the sequential access mode, you can see block 1, block 2, block 3, block 4, block 5, block 6, that way how. So these ones also, I have given that source of this information. Then file organization and access mode, it is the index sequential access method of that record occurrences are stored in order by primary keys on the direct access of storage devices. In addition, a separate table or file called an index is a maintained on primary key value and give the physical address of each record of occurrence. So this approach gives almost direct accessibility to the record occurrence via the index table and sequential access via the way in which the records are laid down in the storage of this formation. So this storage medium is important. Then I have given this data direct access method. So all these things you will find in the internet. I have just whatever giving. When using the direct access methods, the record occurrences in a file do not have to be arranged in any particular sequence on a storage media. However, the computer must keep a track on the storage location of each record using a variety of direct organization methods so that the data is retrieved when needed. So the direct access method, the data is retrieved a method. So what are the advantages of the sequential access? It is simple to implement this file access mechanism. It uses the lexicographic order quickly access to the next entry. It is a sustained suitable for applications that requires access to the all records in the file in a specific order. It is a less prone to the data corruption and the data vibrating and sequentially, not normally, randomly. It is the more efficient methods for reading the large files. So it is a reliable method for backup and more store. So what are the disadvantages? Because everything has an advantage and everything has got a disadvantage. So if the file records that needs to be accessed next is not present and next to the current record, this type of access method is slow. Moving a sizable chunk of the file may be necessary to insert a new record. It does not allow the quick access to the specific records in the file. The entire file must be searched sequentially to find the specific record. It is not a well suited for applications that require frequent update or modification of the file. Updating or inserting a record in the middle of the large file can be slow and cumbersome process. Sequential access can also result in wasted storage space if records are varying lengths and the space between the records or storage of these things. So those kind of things with advantages you have to know. What are the disadvantages of the direct access method? Because complex implementations, implementing direct access can be complex, requiring sophisticated algorithms and data structures to manage and locate the records. The higher storage overhead. So we have to have a higher storage of overhead. The direct access methods often requires additional storage for maintaining data location information such as pointers of address tables, which can increase the overall storage. So I can see that what are the advantages and disadvantages. I have given that sequential, indexed, hash, B-type. What kind of advantages and disease? Sequence is simple, one is slow, one is a fast date, one is a requires the additional storage. One is a have is a fast data retrieve, it can result in a pollution. Battery efficient data retrieval but complex. So those kind of given this one. So the physical database design, the data structures, the following sequential aspects influence that analyzing the data set requires the transactions. So for each query, we should specify the files that be accessed, the files attributes, the author attributes whose values. So then analyzing the expected frequency of the queries and transactions, analyzing the time constraint of the queries and the transaction. Some queries and the transactions may have a stringent performance constraints with respect to the response time, the selection attributes used with the queries, then analyzing the expected frequency of the updated operation. A minimum number of access paths should be specified for a file and that is updated frequently because updating the access paths themselves slow the update concerns. So physical database design. Physical database design, Watson and what says that law of third best. Because what is there? That physical database design says that the law of third best. The best never comes. The second best takes too long and identify the third best. The design that can be validated in time to meet and identified, it can conclude of the conclusion physical database design and no easy fate of that if you feel immediate by it, you are not only one. So now will come that index file organization. So index provides the measures what kind of indexes can be given. Index file is stored, index file is structured. Then the types of the single level means of the order of the index. Index provide what kind of indexes provide index file, index structure, any field. And then the value primary index and then types of the clustering index. Primary index is that it is specified the ordering key fold, ordered file record. Clustering index that use the numbering system. Secondary index it can be specified on any non-ordering fields and data file can have a several sections. Then types of the single level indexes is clustering index, secondary index and then secondary index has also used for numerous levels. So different types of single level ordered system indexes, complexable indexes. So in concluding, I can say that this course has provided an overview of the fundamental concepts of the data structure, file organization, and physical database design. We have explored various data structure, indexed arrays, linked lists, stack queries, trees, graphs, discussions, and their applications. We have also examined the different file organization and the techniques, B-tree, file organization, and all. Finally, we have introduced the concepts of the physical database design. So this unit covers some of the key issues related to the data structures. So the role of the data structures also been discussed in this one. The RAID technology has been discussed, the typical of this one. The DAM technology, ISM technology, we have a discussion. So in summary, this course has covered the following topics: the data structure, arrays, linked lists and stacks, file organization, sequential index, hashed file, B-tree file organization, physical database design, storage devices, file organization, access method, and database techniques. So key takeaways what? Friends, you will take away the data structures are essential for efficient data storage and retrieval. File organization is critical for optimizing the data. Physical database design is crucial for optimizing the database performance. Understanding the data structures, choosing the right data in the right structures. Then I could suggest that you should have develop a database management plan, invest in the data analysis skills. The library should invest the data analysis skills, providing training and support to the staff. Promote the data literacy. Library should promote the data literacy, providing training and support to help the users. We hope this SwayamPrabha course has proved you with the solid foundation of the data structure file organization. Now few short questions, MCQs, answer keys, and at the last we have given a bibliography. You can enjoy this course. I hope this course will give you again a lot of kind of things. Thank you very much. Namaskar.